Let's take a look at how to find the probability of randomly selecting an SAT score that is between an 889 and a 1200. So the first thing that you want to do is draw yourself a bell-shaped curve like what I have on the right-hand side here, and let's mark those two values on the distribution. So 889 and 1200, I'll squeeze in there. And then next, what we're going to do if you're using z-tables is we need to calculate the z-scores that correspond with an SAT score of an 889 and 1200. So the z-score for an SAT score of 889, if we do the calculation, oops, so 889 minus 1083 divided by the standard deviation of 194. This gives us a z-score of -1, which I've already marked on the distribution on the right. And then if you recall from part A, if we do the same calculation, but for an SAT score of 1200, that gave us a corresponding z-score of positive 0.6. So again, I'll mark that on the table here. And then now if we're using the z-table, then what we're going to do is we're going to go and look for the area that corresponds to these z-scores. Remember, the area given in the z-table is always the area to the left. So an SAT score of 1200, I'll mark it on the distribution on the right, has an area to the left of 0.7257. Again, we found that from part A. And then now let's find the area, and I'll mark it in red here, to the left of a z-score of -1. So we need to go to our z-table and pull up the negative z-score. Oops. Let me see, where is my table? There it is. Okay, so let's go to the negative side here and look for -1. And we can see that the area to the left is 0.1587. So let me minimize this. Okay, let's go back here. The area to the left there is 0.1587, but we're interested in the area that is between 889 and 1200. So I'll shade that in hot pink here. I need to know the area in hot pink because the area that is shaded in pink is where we're going to find all SAT scores that are between 889 and 1200. So we can do a little bit of math here, and I hope that you will agree with me that if I take the area in green, so 0.7257, and I subtract the area that's red, the 0.1587, it will give me the area that is in pink. So if we do that calculation, that gives us an area of 0.567, which means that there is a 0.567 or approximately 56.7% chance that we will select an SAT score between an 889 and a 1200. Now, if you're using your graphing calculator, then on the graphing calculator, you're going to use the function normal CDF. And again, normal CDF is going to ask for a lower limit, an upper limit, the mean value, and the standard deviation. So here our lower limit is that 889. It's the value that bounds the lower end of that pink shaded region. The upper limit is 1200 because it bounds the upper side of that pink shaded region. And then now let's put in our sample mean or population mean and population standard deviation. So on your calculator, I'll show you here, we're going to use second vars, which takes us to the distribution. Choose option 2 for normal CDF. Put in your lower bound, your upper bound, the mean, and the standard deviation value, and then press enter. And then you'll see that we get an answer that is very, very close to what we got using the z-scores and the z-table. So here there is a slight difference, and that difference is just due to the fact that we rounded. Okay.